Okay, congratulations on making it to part 2. Okay, so this will be on the binomial theorem. Okay, so we are going to really go straight into the action of how we can expand binomial term into these various components now. Okay, so the last time I just recall that we have gone through the n factorial notation, we have gone through what n choose r is, and so now I'm going to officially introduce you to the binomial theorem. Okay, so now that we have learned the notation, right? Okay, the formula is as follows. Okay, this is given in your formula list, so not to worry. Okay, but I will advise that you memorize. Actually, memorizing is faster rather than flipping the pages forward to look at your formula list. Okay, so in general, a plus b to the power of n. Okay, you can see that part 1 we learn and we are supposed to know what's all these already. N choose r, n choose 1, n choose 2. So it's a to the power of n, and n choose 1, a to the power of n minus 1, b power 1, n choose 2, a to the power of n minus 2, b power 2. N choose r, a to the power of n minus r, b power r, and so on. Okay, so if you want to consider that is there any n choose here, actually it's something like n choose 0, and this is like n choose r, n choose n, sorry, n choose n. Okay, no, not very clear. Let me just write it down. N choose 0 and n choose n. Okay, why is it n choose 0? Because there's no way to choose that. A power n is there's only one way. Okay, so this is how it looks like. Okay, you notice that a few things. Number one, the powers of a will be decreasing as we go down the expansion until it reaches, basically here is like a power 0. And the powers of b will be increasing, power 1, power 2, power r, until it reaches n. And also for n, you also see that it's 1, 2, r, all the way 1, 2, 3, 4, n choose 1, n choose 2, n choose 3, n choose 4, so on and so forth. Okay, so this is a brief intro to the formula. If you are lost, don't worry. Later on, I'll give you an example of how to apply the formula. Okay, can so just so that the formula looks something like that. Okay, n choose 1, a power n minus 1. Okay, n choose 2, a power n minus 2, so on and so forth. Okay, so next, but why is it the formula work? Of course, before we operate the formula, the idea is something like that. So you want to get any term of the expanded form, you think of it as you are choosing, for example, the term, right, from each of the expansion. So for example, right, in this case, let's say if I look at a plus b power 3, okay, a plus b power 3, it looks something like that. Okay, so I need to apply the distributive law. So when you apply the distributive law, for example, if I want my a cube, right, you know that this one is going to give you something like a cube plus 3ab square plus 3a square b plus b cube, something like that, 1331, right? So the thing is, why is it I only have a coefficient 1? Because in this case, you can see that to get your a cube, there's only one way. There's only one way. That's the way it looks like that. That's what has to be a multiplied to a in the second bracket, multiplied to a in the third bracket. Also, you can see there's only one way. You cannot do any other way. So in the same procedure, right, for example, if you are looking at ab square, so you can see a cube only one way. But if you look at ab square, if you look at ab square, how many ways are there? You can see that there will be 3 ways. How? For example, I can choose ab square, I can choose b and b, right? I can choose b followed by, so you can see I use the I can choose like a b, I can choose a b a, I can choose b a. So there are like 3 ways to arrange them. Okay, by choosing a from the first 2 bracket. Okay, let me put for example, let me just make it better. So the one in red, the one in red, basically I choose red, and red. This will give me a square b. Sorry, okay, this will give me an a square b. This will give me an a square b. Okay, or a second way, I use green color. You can see I can choose a and a followed by b, right? So this is the green color one. It will also give me a square b. The third one, I use blue. You can see I can choose a from the last 2 bracket, and I can choose b from the first bracket, that will also give me a square b. So how many ways can I get my a square b? So you think about it, maybe I use a square b. There are basically 3 ways. Okay, and this corresponds to what? Remember the formula? 3, it's like 3 choose 1, right? Because there are 3 ways. Okay, so this coefficient here actually correspond because there are 3 choose 1 ways to choose 1 b from 3 brackets. It's something I can either choose the b from here, from here, from here. So in a way, it's that the number of brackets gives you the number of ways to choose 1 b, right? So it's like 3 choose 1. Okay, huh? So I hope I at least give you some rough feel of how, why is it the binomial expansion, right? We have the n choose r as the coefficient, okay? Because it's like the number of ways to choose the letter, okay? So in general, this is the formula, okay, which I showed the first page. I'll show again. You can see that for the coefficient of a power n, this n choose 0 way, 1 way to choose 0b from n. Yeah, because there's only 1 way not to choose. That means I don't choose my b, okay, and so on for the other coefficient. And the formula goes like that. Note that this r is increasing 0, 1, 2, 3, because 0 means I don't choose any b. 1 means I have basically n choose 1 way, right? It's n ways to choose 1b. N choose 2 ways to choose 2b's. N choose r ways to choose rb's, and so on and so forth. Okay, and it goes on like this. Okay, this is the formula. Okay, so now how do I apply the formula? Let me just go through example 2.1. Very simple show. Okay, so say if I look at this, okay, I want to look at 2x plus y power 5. Okay, so I just look at this. Okay, you can see 2x plus y power 5. Okay, look at this and you see, okay, this is my a. This is my a. This is my b. And this is my n. Okay, and this is of course plus. So I just follow the formula. The formula is supposedly equals to a power n plus n choose 1, a to the power of n minus 1, b power 1. Okay, okay, I mean, I'll just show the first 2 terms now. N choose 2, a to the power of n minus 2, b power 2, so on and so forth. So what is a? This is my a, right? So you can see I write 2x, the whole bracket, the whole bracket, to the power of 5 plus, remember n is my 5, 5, choose 1, 2x again, to the power of 5 minus 1, which is 4. And what's my y? My y is b, right? So it's going to be y to the power of 1. N is 5, choose 2, 2x again, to the power of 5 minus 2, which is 3, and y squared. Okay, ma, can see? And so I will go on. The story will go on. I'll still keep drawing the rest. Basically, is 5, choose 3, 2x to the power of 2, y cubed. 5, choose 4, 2x to the power of 1, y power 4, plus 5, choose 5, which is 5, choose 5 is basically nothing, it's just 0. So it's just y power 5. You can see that my powers of y is increasing 1, 2, 3, 4, 5. Okay, you can see that my powers of x is decreasing 4, 3, 2, 1. Okay, let me just cancel this one properly. Okay, can so this is an example of the expansion. Okay, so do work it out, and I hope you can see. Basically, my answer is here. Okay. Okay, so if in case, do spend some time to work out this on your own, just applying sincere and honestly the binomial formula, and do check your answers against what I have here. Okay, at this point in time, you might want to pause the video just to look at the answers. Okay, so you can see a power n, n choose 1, a power n minus 1, b power 1, n choose 2, so on and so forth. Okay, so it goes like that. And after that, simply make sure you calculate your coefficient until you get 80. Coefficient, you get 80. 5 choose 3, I mean, you just 10 times 2 to the power of 4, so you get 40. 5 choose 4 times 2, so you can see you get 10, and y power 5 is just 1. So I'm just really just applying the formula, and most importantly, you know your n, you know your a, you know your b. Okay, know your terms. What if it's a minus sign? Okay, some people might ask. So very simply, just absorb the minus sign into your B. So treat it as though in this case, if you look at this, right, treat this as your A and treat this whole portion here as your B. Means your B is like minus 3Q in the formula. So you can see that, you see that this is my B, right? Naturally, your B follows. This is your B. This is your B square. This is your B cube. This is your B power 4, right? This is your A, and this is A power 4, A power 3, A power 2, A power 1. All right? I have my n choose R, n choose 1, n choose 2, n choose 3, n choose 4, which is just nothing. Okay? Evaluate the numbers, and this is what you get. Okay, ma? So when you do binomial, you need to make sure your indices is also good. Otherwise, you may get confused. Okay, huh? So next one I go through is basically question 2.1. Okay, how do we do 2.1? 2.1, okay, we are asked to find using the expansion of 1 over x minus 3. Okay, this one, it looks very challenging, but it's not. Basically, it's just something like a sort of a replacement. Okay, so if you let, for example, you take a look at this, okay, say if I have 1 over x minus 3, relate this to this by using B. Okay, you can sort of see that if I let so-called replace this 1 over x to be P, and if so-called I let Q to be 1, okay, so it's some sort of, if I just let 1 over x to take over P, I say replace or take over P, okay, and Q take over the value as 1. Okay, take over is my own language. I mean, you just let 1 over x be equals Q. Okay, 1 over x equals to P, and Q equals to 1. You can see that the moment I do that, this becomes the same as this. This becomes the same as this. Okay, or they are exactly the same. Okay, can so once you do that, then okay, I mean, if I can replace the variable in the question, I can replace the variable in the answer as well. Right, so simply remember what you said, 1 over x equals to P, Q is equals to 1. So remember that just now, remember this is 1 over x, right? And P is equals to 1 over x, right? P is equals to 1 over x. So you have, remember you have this. This was your answer, right? So remember from this onwards, right? You are going to let P to be 1 over x. You are going to let Q to be 1. You're going to let P to be 1 over x. You're going to let Q to be 1. You're going to let P to be 1 over x. You're going to let Q to be 1, Q to be 1, which is why I get this as my answer. Okay, ma? Can 1 over x, that's why you can see x cubed. 1 over x, you can see x squared. 1 over x, that's why you can see x here. 1, that's why you can see a 1. Okay? So that is for replacement of a variable in the binomial expansion. Okay, so next one I'll go to is question 2.2. Okay, question 2.2 basically is about ascending and descending powers. Okay, so what do I mean by ascending? Descending powers means as you expand, your powers is going down. Ascending powers means when you ascend, when you expand, your powers are going up. Okay, so I mean, not very commonly tested, but you good to know powers are going up as you expand. Okay, descending powers means the powers are going down. The powers are going down as you expand. Okay, can so very quickly, I think if you work it out, you will be able to get your answers quite nicely. No big deal, so basically you just treat your, it's just a very simple, humble expansion. It's just applying the formula. Okay, so maybe before you watch my answer, do pause the video to try. Right, so again, you can pause at this juncture. Okay, so I think you're back already. Okay, so you try. Okay, so again, treat this as my A. You can see that ascending powers, right? Your powers of x are going up. Okay, ascending powers are going up, going up, going up. Okay, you don't have to purposely like do it and then worry about rearranging the terms. Okay, so basically you can see here, right, when I do descending powers, what I do is I put my variable term on the left hand side. Okay, the variable term is on the left hand side. You can see it on the left hand side. for descending. And you can see that for ascending, right, the variable term is on the right hand side. Okay, for ascending. So as long as you do that, you just have this small little hack, your powers will be going up, power 1, power 2. This one, if you put it on the left hand side, you'll be going down, power 7, power 6. Because A is the one that's always dropping power, and then B is the one that's always adding power up. Okay, so if you want ascending powers, then put your variable term as the B. If you want descending powers, then put your variable term as the A. Okay, y'all? I hope you get what I mean. Okay, the A in the formula. You can see that if I put it on the left hand side as the A, it goes down. If I put it on the right hand side as the B term, it goes up. And binomial is associative, you can swap the terms around. Okay, so for the next one, I need to expand. I mean, also the same thing. I just use, you can see that if I do it in ascending powers, okay, the guy here, okay, I mean, I have to see who's the more powerful one. Okay, x minus 1 x. You can see that I swap, okay, and this guy, okay, this guy is dropping in power, this guy is going up. Okay, also you can see x is going up, x squared. 1 over x squared, 8. Okay, you can see that the powers are slowly increasing. Okay, not very easy to see when is going up or where is it going down. So most importantly, remember, this guy, the higher the power it gets, the lower the, the bigger, for example, if I put to power 9, the bigger this number, the more negative your power. That's why we want this guy to be the A, so that it goes down. This x, because it's a positive power, you want it to go up. That's why I put it on the right, because I want it to go up. I put it on the left, because I want it to go down. And vice versa for part 2. Okay, so do try your question before you watch my video. If you before I go through the answer, do pause your video to try it first. Okay, so you don't have to rearrange. Okay. Okay, for question 2.3 and 2.4, okay, I'm going to leave it to your teacher, math tutor in class, to go through with you. Okay, I think it's quite worthy to let them discuss with you. Okay, so that will be all for the binomial theorem. Thank you for listening, and we will see you in part 3.